My name is Niall Deehan. I'm that one. And this, of course, is Elliot MacGyver, my faithful hawk. So today I will be talking about how Camunda plays with others. That's a nice way of saying how Camunda can actually communicate with other systems and other means of communication, both when things go as expected, but more importantly, when things go wrong. So I want to start off with a nice beach effect going on. I want to start off by basically talking about I would say the most uncommon possible scenario when you're trying to communicate with other systems, and that is when we play with others that we like. That is stuff that we can make certain assumptions, that when we're trying to communicate with other systems through Camunda, that we make certain assumptions that are things like, for instance, that we want to design the most likely scenario. We'll just build a model that gives us exactly what we expect to happen, and we will hope that kind of works that way. Generally speaking, we want to assume that the service you call will be successful. Okay, that's something that sometimes gets designed. And also, if other processes are called from your main process, that thing will eventually sort itself out and then complete successfully. And that won't be a problem. And finally, if something does go wrong and something inconsistent happens, we can handle that by transaction rollbacks. Now, this is the happy path. This is the idea of designing something that we expect will be a great success. And therefore, I've decided to think of a pretty good metaphor for this half. The second half will be a little different. But first of all, who here flew into Berlin for this particular conference? Okay, great stuff. Who here flew into Tegel Airport? Beautiful place, you lucky people. It could have been so much worse. So Tegel, of course, is a wonderful airport north of Berlin, and it was constructed in a very simple way. It had a process that looked like this. Okay, pretty simple to predict. If before they started, they thought, how are we going to build this airport? It was really simple. People of Berlin needed a new airport. Made sense. Then the government decided to hire a company to build the airport. Very soon after that particular company decided then to design the airport. We then had the scenario where we have that little sub-process there. We constructed the airport, of course. The airport was then announced that it was open. Very good idea. We then waited until that time, and when it was over, Berlin had an airport. Fantastic. That seems to work great. So let's have a quick demo of this. So let's just go here. So right now, I have the process deployed. It looks like this. And I'm going to step through it. Now, what I'm going to do is I've used a very different means of communication throughout moving each token. So when I start this process, I'm going to start it for task list, because if the people of Berlin want something, the people of Berlin should have UI. OK, so I'm going to start here, and I'm going to say airport management. And I'm going to say TXL. We're going to have a nice budget of that's probably around 10 million or something. We'll have a key of 1 maybe, and airport opening time. Well, this app opened a while ago, so I'll just dump it last week. And then we'll stay start. OK, great stuff. So what's happened? So if I refresh this, OK, we have progressed quite well. We have the government has managed to do something quite quickly. They've hired a company already, which is great. Now, why did they do that so quickly? Because if we take a look at the model, and you'll see I'm using a particular plugin that might be relevant, we have here that this is doing what used to be the most common way of actually calling services, which is we have a project, and we're basically calling a Java class directly. Not much can go wrong when that happens, because there's no network involved. It basically means that we have our project, we have our model, and then we also have the Java class deployed with it. So we don't need too much communication, and therefore it just went right through, ran the class, and then waited. Okay, so this is the easiest kind of communication because it's entirely local. I decided not to do this for this designing airports. Instead, I used my favorite way of communicating, which is external tasks. So the idea here was we wanted to say the process is going to wait here. It doesn't actually know where the business logic is running. Instead, it's saying, if you know how to do this design airport thing, then let us know. And then we'll go and run that. So in this case, I built a worker using JavaScript. Okay, so this is a external task worker. Who here uses external tasks in general? Okay, I'm going to try and convert the rest of you. External tasks are really fantastic. This guy here is from the Node.js client that we support, which allows you to basically be able to say, okay, this is a completely independent bit of code. What it's doing is it's essentially got a URL where it's linked to Camunda, where it's saying, this is where I will find my work. It then is subscribing to the topic it knows it can do. In this case, it can design an airport. And then next, it will simply do some sort of business logic and then complete the task. Okay, this is really nice. There's a few big differences between this and the Java class. The first main one being that the Java class is single-threaded and cannot scale. Okay, if we wanted to make this run a lot, we would simply start lots more of them up, and they can become multi-threaded. Well, we can have more than one thread working on this particular task rather than the previous version. Another nice thing is it's, of course, in JavaScript. We're essentially language independent once we start using external tasks. So if your business logic is in C# or something, then you can do that as well. So all I need to do now is start this up, theoretically. Where is, oh, I have a mouse here, great. PowerShell. Okay, so then, okay, so I'm going to start this, and it's subscribed to the topic. It completed the task, and then it went back to subscribing. Now, that word polling is a little bit misleading because it is polling, but I've set it so that it basically does a long polling method, which means that it's going to hit the engine, and it's the engine to hold that thread until work comes in. It's important because it means that if you have lots of workers, you're not going to have lots and lots of polling constantly. You simply hold the thread. Once the work comes in, then we get it back to, and you can set that limit. This is relatively frequently. Okay, that's good. Now let's see how we're getting on in Cockpit. Okay, great stuff. We are now on Construct an Airport. Okay, let's take a look at that. Oops, let's actually go here. Actually, yeah, we'll go in here. So this is obviously a different process. Let's look into this. So this is really simple. We start our process, we purchase materials, we then build a section of airport, and if we need to build more airport, we purchase more things and build more airport. Okay, eventually we will run out of budget, in which case we'll just keep going this way. So this is also an external task. Let's try and open this up. There we go, purchase materials is an external task, but I'm actually not going to use, I still like Java just because I can choose JavaScript. I would never, but if I wanted to, I would. So I'm going to choose Java because it is my preference. So right now, I've essentially made in here a worker that works in basically the same way because it uses the same pattern as the JavaScript worker. Now what that pattern is it has a REST. There we go. It basically is making REST calls, okay? And in this case, it's subscribed to the same thing. We have an async timeout. This is actually the long polling that I talked about. If we add this, it means we're going to hold the thread for longer. And then we also have our subscribe to whatever. We have our lock duration there, and then we do a whole bunch of stuff. In this case, we increase the cost every time we want to build something. So in the same way, I'm just going to start that up, and that is... Nope, there we go. Okay. Oh, okay, loads of stuff happened there. So you see that info says an external task has been completed. It also happened a whole bunch of times, really, really quickly. So why did that happen? If we take a look at this, it happened 11 times because we looped around 11 times. So 11 times that task became active, and we quickly did all of them. So that means that we should arrive quite happily right at the end of our process. The timer probably fired. Oops, management. Here we go, history. Timer fired, and now we're done. Fantastic, Tegel is built, rejoice everybody. Okay, so that of course is the most unrealistic scenario for calling other systems because everything kind of just worked. So let's talk about another pretty good example about that we can deal with when we talk about how to communicate with others when those others are not being very nice to us. And this example also comes from Berlin, and this example comes from slightly further south. It is an airport called BER. Who here flew into Brandenburg Berlin Airport when they arrived in Berlin? Nobody. Wow, imagine that. So this airport has been quite a while in the making. For those of you who don't know, who aren't locals around here, Berlin-Brandenburg Airport originally started construction in 2006, quite a while ago. But luckily, it only cost 2.83 billion. It's perfectly reasonable for an airport. And it was going to open in 2011. It almost did, but luckily they only shifted it by a year. So then we ended up having to wait till 2012. Then we had to wait till 2013. Then October, still same year, 6 more updates later, and have no fear, you'll be flying into Berlin-Brandenburg Airport in 2020. Current cost, 9.4 billion. Okay, so a little over budget and took a little longer. So this is definitely a more accurate scenario for trying to communicate other systems. We need to deal with things that might go wrong. So what kind of things went wrong with Brandenburg? Well, first of all, certain things are you have to design the possibility that if you try to do something, you might fail at it, and you can't always throw money at it to fix it. You can assume a service will fail. If you are trying to communicate with a service and it says, thanks for that, but I'm going to fail, not in a technical sense, but in the sense that with what you gave me, I cannot achieve that. That's the type of failure we're talking about, meaning that the code all ran correctly, but for whatever reason, we couldn't do what we actually wanted to. Also, so other processes that were called, so if you, for instance, ask, hey, build an airport, you would assume that an airport would get built. But sometimes things happen within that build process that means that you actually cannot complete that correctly, and you need to be able to deal with that as well. And then finally, rollbacks might not be transactional, meaning that you might have done something in a different transaction that needs to be fixed. You cannot rely on being able to roll back a transaction boundary. Okay, so quick demo, caveat. Everything quick about BER does not exist, so this may take a little longer than assumed, so give me a break on that. So let's go ahead. So I'm going to build these, so I'm just going to say, open up this little model. Okay, and the first thing that happened with BER kind of happened here with Design Airport. Design Airport had a tiny problem, which was about halfway through designing the airport, they realized the airport they were designing was too small. So let's deal with that. So there was an error event, and they said, airport is too small. Great stuff. And that was fine because obviously if the airport is too small, but it's kind of been designed already, there's an easy fix. You just add, I don't know, ++ to every single measurement. And that shouldn't have any problems. So let's just say add more things. Okay. There we go. It's a nice little service task there. Okay, then we return back. We've got that problem sorted. The next little problem probably came with while constructing the airport. So let's open up this guy here. So here we have a very simple loop which says, while we're building, we keep doing stuff. But unfortunately, while there was still more airport to be built, there was no money for that. So therefore, we need to do another check here, which is just going to be something like, is there money? And this is a great control that we can make sure that we don't start building stuff if we don't have money. But we do need to tell the people that asked us, hey, just so you know, we can't build this airport. I know you asked us to, we're a call activity, we're a sub-process, but we actually can't do it. We need to tell them that this is your problem now. So we can do that by basically sending a escalation event. And that will actually go to the next scope, and there we go. And this is going to say, need money. Great stuff. So what do you think happened next after we said need money? We wait for that money, yes, because there's no other option. The airport is on the way, so you might as well just go with it. So wait for money. Okay, and once that money arrives, we will then go back to purchasing stuff. Okay. That looks relatively okay. Alrighty. Maybe a little cooler. There we go. Okay, so Now, obviously, while the sub-process can send this, it's up to us to deal with this problem. So we are then going to be able to say, OK, well, while you're constructing this, I'm aware that what could happen is you could have some kind of escalation where you need money. And of course, this is the government, so they're very efficient, so they will straight away just increase the budget. OK, that makes sense. And but we need, the really cool thing is, and this is something that we get asked about quite a lot, is that we actually need to tell this sub-process that you can now go ahead, that we've done that. And so once we increase the budget, we can then send a message to say, OK, the budget is increased. OK, go buy stuff. Alrighty, so this is then going to tell our sub-process that now we can go back around. OK, so yeah, so the next thing that happened was this was all going great, and then we had this very important problem, announcing that there would be a date of opening, and then just waiting for that to happen. Any idea of what might happen between here and here? Yes? Many new problems, yes. So we actually need to deal with the idea that we cannot open on the time we normally do. So we're going to use an event-based gateway. So we're going to say, very simply, let's say, I don't know, new opening date is required. Then we really simply add problem to list, because I'm sure the list is there somewhere. I think there is a website that shows the list of problems, actually. OK, so, and once we're done with that, we will then head back here. Alrighty. OK, that seems to make sense. So then we have a nice little loop here where we're waiting. Problems could occur. We'll add to the list. We'll deal with it later, no problem. And we'll just keep on updating that lovely due date. And we also have one other thing that they did at this point, which was once a problem happens, the very first thing you want to do is find someone to blame. This is probably something everyone's aware of. It's the primary focus, usually. So we actually need to make sure we fire whoever it was we hired here. OK? So this is something that we need to do well after we've completed this, so which means that I'm going to use, maybe before we add to the problems list, we will throw a compensation event. There we go. So what compensation does is fire someone. OK, so compensation basically says, OK, something has happened now that I need to undo, so I would like you to make sure, go back to the tasks that I've completed. Those that have a compensation catch, I would like you to please run the corresponding task. So let's head back over here to hire. Let's pop this guy here, and this is going to be a compensation boundary event, and we will have as a service task here. OK, and this is going to be something like fire everyone. OK, so this worked great. This is why they opened on time. So let's save that. So this is all designed so far. Of course, we would quite like to be able to see this executable. So I'm going to run through this now and just show you. Right now, all I did was just design. OK, so now it's execution time. So let's turn this into something that might run. So first things first, I need an error event. Luckily, I can copy paste a whole bunch of this because I did some prep. So there we go. So we need to add this airport too small is the code of our error, which means that this task, the system's being called here, is in charge of telling us that it managed to fail. And so airport too small is the error we're going to throw. OK? So if this throws that specific error, we're going to catch it, we're going to do more things, and then we're going to continue. So I'm just going to have a quick little placeholder for this. There we go, great. OK, so next up, we also have the idea that this guy here needs to throw this event. This escalation event is going to be called budget exceeded. I prepared that. You can just type in. So this means that when we get here, we're going to send an event to the next scope up and say, hey, an escalation has happened. An escalation is kind of a nice event because it means that we can continue. It's not that big a problem, but you should probably do something about this, which means that we are then going to catch that exact same event here. Great stuff. And once we do, we'll increase the budget, which I'm fairly sure is a Java class. Okay, so to that I just need to grab the qualified name. This is just going to, it's pretty straightforward, this is just going to increase the budget by a couple of million. Nothing too drastic. And let's pop that there. Great stuff. Then we're going to arrive here. So now we need to deal with this. So this is going to be our opening date. Let me just grab the specifics. Actually, let's continue back in the sub-process first. So once we get our money, we then need to wait for a specific message to say the money's arrived. So the budget increase message. So this is going to be an event saying, give me some money, and then we get it. Then we return back this way. I also need to change this gateway because there are some limits to even the German government's money. So let's say after 7 billion, we just got to stop. And this guy here, there we go. So we have an expression here that's going to say, if the cost is greater than the budget, then we go this way, and then otherwise we will go this way. Okay, that should do that. So now we need this guy here. So this is our conditional event. Let's grab that condition. There we go. So condition is date changed. This is a really nice event because what we can do is we can say, as long as we are waiting at this point, we are actually waiting for two things that might happen. We don't know which one. Either the time elapses or this variable called date change becomes true. And I can specifically say, let's just wait for this specific variable name. And very importantly, not to cause an infinite loop, I also then need to make sure I change it so that it actually sets it to false then. And I'll do that in a really sneaky way. See, listeners, great, aren't they? They're visible now. So then let's just grab this. So just a script, JavaScript. Okay, there we go. And that should more, yeah, need this thing as well. I think that is also a Java class. There we go. So again, this is just going to send a message. It's also going to send the new budget. Okay, so because when you would call a subprocess, it basically has its own copy of the variables, we're basically telling the subprocess your variables have now been updated. So it's increasing the budget and sending that update to the subprocess. Let's grab that. And this is going to be a Java class. Okay. So before I go forward, has anyone spotted something I missed? It's a legitimate question. I don't know. I've done a lot of stuff now. So, Sebastian, you're laughing? You're just expecting something bad to happen? Okay, fine. You're the wrong person to ask anyway. Okay, so let's see if this works. So I'm just going to build this and deploy it. Now, luckily, I don't need your help. Not that I don't trust you, but we do have some testing going to happen. So I'm going to run the unit tests, and it's going to see if I've missed something really simple that it can't be deployed. So I've got some warnings, but they're fine. Tests, here's the important part. Oh, it's taking a while. Okay. So this is building the engine. This is starting in memory, starting up some H2 database in memory, and then it's going to fail badly. You guys are not paying attention at all because obviously I missed something. Yeah, good question. Where is that? So I've got a service task that I forgot to add stuff to. So let's do this. There it is. Great. Did you ever know about the Control F feature on the modeler? It's a search. You can Control F and find. You can type in the That is was a wonderful secret feature, I think. We don't tell everyone that, so keep it to yourself. Okay. So, are there any more? No, we're good. 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 Aha! Sneaky guy here. Alrighty, so that should do the trick. Unit tests aren't all bad. How's my time? Okay. That's it would not at all be ironic if I ran out of time trying to build BER, but I feel more confident. Alrighty. Is it looking better? Fantastic. So let's deploy that. Okay. Copy. Let's run to the deployments folder. Drop that there. Replace the old one. Okay. See, now's the fun part where we find what the runtime errors are. Okay, so if we go here, we should have our shiny new process. Once again, the people of Berlin have spoken, and they would quite like an airport. This time they would like, oopsie, construction, nope. Process, airport management, BER, yeah, that seems like a reasonable amount of money to spend. Let's do, I don't know, let's open tomorrow. I'm feeling very confident. And let's see what happened. So first of all, we're waiting for our process to run. So let's grab that. Let's just click on history view. So let's start that up again. Workers, actually I have my Node.js one. Let's kill this one for a moment. Okay, great stuff. Okay, so this now says it handled a BPMN error. This is slightly different to the first version. The difference being that if we get a variable called airport code, we check if it's BER. If it is, we throw an error that it's too small. And this allows the process to basically, this thing has technically been successful in the sense that as far as this worker is concerned, it has done everything it's supposed to. So this is an error that we can handle here. So let's check out what happened. Okay, great success. It stopped here. We've made things bigger. Awesome. And now we're in here. We're in this sub-process. And now we're here in purchase materials. So that seems pretty straightforward. Let's start up that process again. Great. This should not take too long. Okay. Ooh, that's not good. I'm sure that's fine. Nothing ever goes wrong in demos. Okay, what's happening? Okay, 10 times, then it stopped. Doesn't seem right. Try that again, dude. Ooh, that's not good. Okay, so predictably an error has occurred that I didn't expect. So, oh, did I do the wrong thing? I think I did. Let me see if I can fix it. I'm going to fix it in the easiest way possible. I'm going to go to my backups. Haha. See, this one looks even better. And I'm going to make it executable, very important, and I'm going to just deploy it. Let's hope for the best. Okay, awesome. Different name. That could be a problem. Okay, so now let's do some random migration because that's going to be fun. So let's migrate this to the new version. So can you go here, please? You can't. Oh, no. Okay, new plan. Okay. Let's do this. So I'm going to drag this lovely token here. Oops, if I can. Yeah. Maybe I'll put it here. So what should happen, theoretically, is that I should call the new version again. Okay, looks all right. And how's this guy working? Oh, that's painful. Okay, so bad news, guys. We don't get an airport, but we will drag this over here and run it because just because the airport isn't built doesn't mean we can't have a opening date. Okay, so there we go. So then we've now done our thing where we basically skipped that whole construction thing, which who does it anyway? And we decided to wait here for either one of these two things to happen. So now let's really test if this thing is going to break, because I'm going to now decide to create a variable. Let's do that in the runtime. And that variable is called, hopefully saved, date changed. It's a Boolean. It's true. Great stuff. So that meant that we should have spun around, run down here, ran this added list of problems, run up here, and then wait again. And we should have also triggered this fire everyone task. Okay. So basically that is an attempt to show you guys how, while building a process that plays quite well when things go right, it's actually more useful if you prepare for things that will almost certainly go wrong, and also be able to have a whole bunch of tools available to fix those problems. Or just, everything you build breaks, which is also fine. Okay, so thank you very much. Hope it was useful. And I'm open to any questions that might be floating around.